Hi, in this video we'll do some examples from Chapter 6, Section 3. Again, we're going to do some more examples where we're solving differential equations. So once again, we want to get all our x's, including our dx, on one side and all our y's on the other, including our dy's. Okay. So the first thing I'm going to do is subtract my x squared each side. I end up with 5y dy dx equals a negative x squared. And now you can see here, all I have to do is multiply each side by my dx, or just bring it up here. So I'm left with 5y dy equal to negative x squared dx. And now the way I can solve this is by integrating both sides. Right? The integral of 5y is 5y squared over 2. And now our integral of negative x squared is going to be negative x cubed over 3 plus my constant. And now if I want to, I can see that this is probably going to be a move everything to one side. But if I want to, I can get rid of my fractions by multiplying through by 6. Okay. I don't have to worry about the constant because there again it's constant even if I multiply by 6. So these cancel out, give me 3, so this first term becomes 15y squared. These cancel out, leave me 2. If I move it over, this is a negative 2x cubed, so I'm just going to move it over and make it a positive 2x cubed, and then that's equal to c. So that's your answer. All right, let's try one more. Again, same idea. In this one, I've got it written as y prime, so I'm just going to change that to dy dx. I want to get my x's on one side, my y's on the other. All right. So I need to get this over and this over. I'm going to divide by the square root of 1 minus 4x squared, and then multiply both sides by dx. And what I end up with is dy is equal to x over the square root 1 minus 4x squared. This goes to the denominator when I divide both sides by that. Do the dx. And now to solve this one, again, once my variables are separated, one on each side, I can integrate each side. The integral of dy is just y. And over here I see that if I can get the derivative of what's underneath the radical, all right, then I can just treat this as 1 minus my u as 1 minus 4x squared. That would mean my du would be minus 8x. So I've got the x, I just need the minus 8, so I've got to put a minus 1, 8 out here. So it gives me minus 8. And now I have u to the negative 1/2, because that's in the denominator. So that just, the derivative of this is just going to be u to the 1/2 divided by 1/2. Okay? So in other words, this becomes 2. All right? When I move this up to the numerator, multiply by 2, this goes away. Okay, and then u to the 1/2. Well, my u is just this, 1 minus 4x squared. And then I have to have my constant. Of course, I can simplify that slightly more by going ahead and multiplying out that first part. I get y equals, and then that's just going to be minus 1/4. Okay, 2 times negative 1/8. Square root of 1 minus 4x squared, and then plus my constant. All right. So again, once we get the variables separated, we can just integrate both sides and come up with our general solution.